We're now having a look at, under our analysis section, looking at unusual values. Now there are two types that we're going to specifically look at. We're going to look at outliers, and then within a group of outliers, some of those outliers will be what we call influential points. So we'll have a look at this. So when we talk about outliers, outliers could be a point that's got a very large x value that's compared with other values. Okay, it could have a very large y value, it could have a very large x and y value, or it could be just a point that is quite distant but hasn't got an extreme x or y value. Let's have a look at some examples to show you what I mean. So if I look at, for example, just something that's got an extreme x value, I look at this point here and you can see that there's quite a gap between on the x-axis. It's quite a lot further along that x-axis than the other points are. So that will count as an outlier. We also can look at extreme y values, and so comparative to the other y values, this is a point that's quite a bit further away on the y-axis. If I now look at values that are extremely on the x and the y-axis, there's an example here where in terms of both its x value it's much further away and its y value is much further away. We could also talk about distant points, and so we've got an example here where if I look at that point there, its x value and its y value are similar to the other points, but it doesn't belong with that group of data that the rest of the data lies by. So that's why this will also be what we call a distant point, because it doesn't fit with the pattern. So when we have influential points, that's when some of these are outliers. Well, they are outliers, and some outliers are also influential points. So these are influential because they have a big effect, and either it affects the regression line and/or it can affect the correlation coefficient. So this is what we're going to use to determine is it an influential point or not. So if I'm going to look at an example and I'm going to compare what happens when we have the outlier included in the data set and the outlier excluded. So here I'm going to talk about when the outlier is included. And we're going to look and say, well, the line of best fit, and you can see that that line of best fit is being pulled down at the top end towards that outlier. Okay, so the gradient of that line is being pulled down towards the outlier. The correlation coefficient for this is about 0.4, and the equation is around y equals 2x plus 3. So that's when we have the outlier included. Now let's do the same thing, but now we're going to remove that outlier, and we're going to reapply the line of best fit. And you can see that this line of best fit now fits much better through the rest of the data because it's not being pulled down towards that outlier. Okay, if I just go back, that was the line of best fit. The gradient was quite a lot lower, and now the gradient has increased and moved up. So our correlation coefficient R has increased up to 0.7, and the gradient on the line of that best fit is now y equals 4x plus 3. So this shows at that point, okay, that outlier that we removed, that is an outlier, and that point is also influential because it's an outlier because it's a distant point. Okay, it's not a necessarily extreme x or extreme y values. It's just distant. Removing that value has a very big effect on the correlation coefficient. So we had an R value of 0.4, and that would mean quite a weak linear relationship. And when we remove that one point, the correlation coefficient changed to 0.7, which is now a moderate linear relationship. So taking away one value changes the R value from 0.4 to 0.7. So that's quite a big change. If I also look at the gradient, our gradient was 2 originally with the outlier included, and when I removed the outlier, the gradient changed to 4. So that's changing our gradient quite substantially. It's changing it from an increase in the y-axis of 2 for every 1 unit change in x, up to an increase of 4. So it's doubling the gradient. The gradient has doubled. So now let's have a look at the fuel efficiency example. So we first need to look visually and see, are there any points that might be outliers? So looking at our graph there, we can see that there's a couple of points up the top there that their Y values might be a little bit higher than others, so that's why I'm saying they're possible outliers. Then we need to draw the graph with the point labels turned on, and so that's an option in NZ Graph, is just to put the point labels, and we are going to find what point that they're point number 79 and point number 47. We also want to have taken note of the correlation coefficient value and the gradient value. So here is our line, and there are our 2 points, point number 79 and point number 47, and we then go to the data set itself to identify what those points are, so what kind of car they are, what kind of engine size it is, etc. We're also going to notice the R value there of negative 0.84311, and we're going to notice the gradient value, negative 0.017709. So now we're going to draw that graph again, and we're going to remove these 2 points, and we can do that with NZ Grapher. There's an option there that allows us to remove particular points. We want to again look at the equation of that line and the correlation coefficient. So we can see now that the correlation coefficient has now become negative 0.87441, and our gradient has changed to negative 0.015625. So let's think about how much that has changed. So in terms of the correlation coefficient, when I have the outliers included in the data set, then the correlation coefficient is negative 0.84. When we remove the remove the outliers, that changes that correlation coefficient to negative 0.87. So it isn't changing it by much, it's only changing it by 0.03. So it's still, for both of those values, I would still classify it as a strong linear relationship. So there is very little changed there. Then look at the gradient. When I have the outliers, my gradient, M, is negative 0.0177. Without the outliers, so when I remove them, the gradient changes to negative 0.0156. So that gradient has barely changed. It's only changing by about 0.002. So that means both of our correlation coefficient and our gradient have barely changed at all when we remove the outliers, and that means those points that we removed are simply outliers or possible outliers, but they are not influential points. So how do we talk about them? Well, first of all, we've got to talk about them as outliers, and we can talk about how there are 2 cars, because there were 2 outlier points, that have a higher fuel efficiency rates than expected, because that's the high Y values. Now, Y-axis is the fuel efficiency, so we're saying that they've got higher fuel efficiency than expected. And this is when I go and look in the data set and find point number 49 and point number 67, and I find that one of those points is a Geo Metro, that's a type of car, and has a weight of 769 kilograms and a fuel efficiency of 46 kilometres per litre in the city. Then I found my second point, and that's a Honda Civic car that has a weight of 1,066 kilograms and a fuel efficiency of 42 kilometres per litre. So I've identified those particular points. And what I can say about both of them is both of them have quite small X values, which means both of them have got very small engines, and so that may be what's increased their fuel efficiency. Now, you may or may not be able to come up with that explanation, and that's okay, you don't have to. It's only if you know enough about the particular topic that I expect you to do that. So then we do our influential check. We talk about, well, when I remove those points, our correlation coefficient changed from negative 0.84 to negative 0.87, which is only a increase by 0.03, which is a very small change, and that shows that it's had a minimal effect when I remove them. Same with when our gradient changed from negative 0.018 to negative 0.16. I've rounded that, by the way. So that's a tiny change of 0.002. So that means that these points are both outliers, but they are not influential points, because when I remove them, they have such a minimal effect on that line of best fit and the regression coefficient. And there we have it.